Is it possible, under certain circumstances, to break the laws of physics? To understand how the world works at a fundamental level, you have to study the four basic forces of physics. We experience their effects everywhere. On Earth, gravity is the fundamental interaction that's most clearly apparent. It's what holds celestial objects like planets in their orbits and affects everything that has mass. Its influence shrinks with distance, but at least within our galaxy never disappears completely. The second force, electromagnetism, is what makes electricity flow and causes magnets to either attract or repel each other. The last two forces have less visible effects because they influence events at the atomic scale. The strong nuclear force is what binds the particles in an atom's nucleus together. The weak nuclear force comes into play when atoms decay or combine with others. These four fundamental interactions don't just apply on Earth. Physicists believe they've influenced the development of the universe since its earliest beginning, when it was born out of the Big Bang, around 13.8 billion years ago. They think that a tiny fraction of a second after the Big Bang occurred, gravity was born. That would make it the oldest of the four basic interactions that give order and structure to our world. If the properties of just one of the forces changed even a little bit, it would have consequences throughout the entire universe. Some phenomena reveal what effects the forces can have at their extremes. A black hole is born when matter grows so compact that gravity becomes the overwhelmingly dominant physical force, essentially ripping a hole in the fabric of space-time. We can't change the four basic forces in physics, but we can harness them. For example, we can split atoms to create nuclear energy. Space travel opens doors to other possibilities. The International Space Station orbits the Earth so fast that centrifugal force effectively cancels out the Earth's gravitational effect. And in the weightless environment that produces, water and other types of matter behave very differently than they do here on the surface of our planet. Another visible effect is with fire. On Earth, a candle flickers because the air around it rises as it heats up, pulling the flame upwards as it ascends. On the ISS, though, flames take on a round, spherical shape. They don't flicker because hot air doesn't rise there. On Earth, warmer layers also rise to the surface in a liquid medium, in what researchers call convection. That effect, for example, prevents protein crystals in the medium from growing uniformly. But under weightless conditions, the molecules are able to move more freely, so they can form crystals that are larger and more perfectly shaped. By increasing our understanding of how proteins work, these crystals have helped in the development of tailor-made drugs. It's just one area of research where minimizing the effects of gravity has provided completely new insights into the fundamental essence of the universe around us.
That's it for now. Next week, we'll be looking at eco-friendly plastic made from CO2. Researchers are exploring it as a raw feedstock material. That and more next time on Tomorrow Today. See you then.